Hey there, in this video we're going to discuss section 2.8, continuing our discussion of one-to-one in finding the inverse of a function. So what is the inverse of a function? So in order to have an inverse, the function has to be one-to-one. So our definition says let f be a one-to-one function with domain A and range B, then the inverse function, and we use the notation of f to the minus 1, has domain B and range A. So and the definition here is that f inverse of y equals x means f of x is equal to y. Now, one of the things that I want you to be careful about is that f inverse of x is not the reciprocal. That does not mean 1 over f of x. So this is very important to remember. Right? Don't make this mistake. The f to the minus 1 means the inverse. Okay, so what does that mean, that f inverse of y equals x for any y in B? So essentially, when you have your domain, right, A here is the domain and B is the range. So f takes an input from the domain and sends it to B, the range. Now what f inverse does is that it takes now the range, the original, what was the range, now becomes the domain. And so f inverse sends it back. So that's what it's doing. So it's you can kind of think of it as the opposite. So for example, if I have a function f of x where I have my x's, x and f of x. So say I have 2 goes to 4, 3 goes to 5, and 6 goes to 8. We can kind of maybe guess what this function is doing. But what this then is saying is, what is f inverse going to do? So if I have f inverse of x, what f inverse is going to do is it's going to take what was my range, right? This was my range B, now becomes the domain in f inverse. So B is now the domain. So what that means is that when f takes 2 and sends it to 4, what f inverse is going to do is it's going to take 4 and send it to 2. And when f was taking the input 3 and sending it to 5, f inverse is going to take 5 and send that back to 3, and so on. So the outputs 4, 5, 8 become the inputs, and what were the inputs now become the outputs. So x will go to y, and what this says then is that y will go to x. So that's what the inverse is doing. And so what we can say is, therefore, if the point xy is in the graph of f of x, then the point yx is in the graph of f inverse. So it reverses it. So let's try an example of finding the inverse. So let's say let f of x be 2x plus 5. And so in this case, think about what is happening. So x is my input. And back when we did functions in the very beginning in section 2.1, we talked about writing this in words. So what is happening? What is this function machine doing? So essentially, we're taking the input, we're multiplying it by 2, and then adding 5. So the inverse does the opposite. So just in words, I can try to think about what the inverse is going to be. Right? So this says that we take the input, we multiply it by 2, and then add 5. So to reverse that, the first thing I'm going to do is subtract 5. So I'm going to take my input, subtract 5, and then this says you multiply it by 2. So the reverse of multiplying by 2 is dividing by 2. So this is what I'm thinking the inverse will be, but let's do it algebraically. So algebraically, we're going to use this notion that if xy is in f of x, then yx is in the graph of f inverse. So what I'm going to do first then is say, I'm going to say y, call f of x y is equal to 2x plus 5. So then highlighting what this says is that if xy is in f of x, then yx is in f inverse. So xy, this is my f of x. Then that means that I should be able to then say, well, then yx is in f inverse. So this will be how I'm going to find my f inverse of x. So that's my yx, right? Y became the input and x became the output. And so now let's solve for y. So when I solve for y, I have to subtract 5 from both sides. So I'll go ahead and do the subtract 5 from both sides. Here they cancel. On the other side, we don't have a constant term, so this just becomes x minus 5 equals 2y. And then to get the y by itself, divide both sides by 2. And what do we get? We get that x minus 5 over 2 is equal to y, which is our f inverse. So therefore, I can say f inverse of x is equal to x minus 5 over 2, which notice is what we got up here. So they are the same thing. Here we just kind of did it by reversing our words. Right? This one said you take the input, you multiply by 2, and then add 5. So reversing it, you reverse the last thing you did. So the last thing you did was add 5. So we're going to reverse that. So that means we're going to subtract 5. So we're going to take the input, subtract 5, and then divide by 2, because that's the opposite of multiplying. With linear functions, it just works out really nicely to just do the reverse. But as our functions get more complicated, that's not going to work so nicely. Now we can check to make sure that we have the correct inverse by checking if this is correct using the property of inverses that says f of x and f inverse of x are inverses if and only if, so if and only if f of f inverse of x is equal to x. Or you can use the other way, f inverse of f of x is equal to x. So if you do the composition of functions, then you should get x. So in this case, we're saying f of x is equal to 2x plus 5, and f inverse, I'm claiming, is x minus 5 over 2. So let's see if they are in fact inverses. So to check, I'm going to find f of f inverse of x, which means then everywhere I see an x in my f, we're going to plug in f inverse. So this is going to be 2 times f inverse of x plus 5. Let me put parentheses around here just to make sure. And so let's plug in f inverse. So this becomes 2 times f inverse, which is my x minus 5 over 2. Right? This is my f inverse of x. And then plus 5. So here 2 divided by 2 is 1. So those cancel, and I'm left with x minus 5 plus 5. And minus 5 plus 5 is 0. So we're left with x. And so that means that they are in fact inverses, because two functions are inverses if when you compose them together, you get x. So let's try another example. Let f of x equal x over x minus 2. And so go ahead and find f inverse of x here. And I'm going to stop this video here, and in the second video, we're going to find this one.